Good afternoon, everybody, or good morning, depending on where you are in the world today. I'm delighted to welcome you to our live webinar on trends in biomaterials and recycled as raw materials for the plastics industry. I'm kindly joined today from experts in the industry, Mark Billham and Alan Clarke from the Polymer Processing Research Centre in Queen's University, Belfast, to share their wisdom and expertise with us. And also with Bertil Kapff from WTS, a global expert in the world of taxation, to talk to us about the regulation and plastics taxation within Europe. At this stage, just to note that this webinar is being recorded as we speak live. The link will be shared after the webinar. So we will be starting with Mark Billham, which will present on behalf of the PPRC from Queen's University Belfast, and to bring us through this interesting content on trends in biomaterials. It's obviously a big area of discussion in our industry, in the plastics industry, and looking forward to learn as much as possible today from Mark and the team. So at this point, I'd like to hand over to Mark. So you'll also be able to make yourself unmute yourself there, Mark, and we'll be able to continue on from here.
Okay, thank you very much, Shane. I'm looking forward to presenting this. And as you can see, and Shane's already mentioned, the title of this presentation is Trends in Biomaterials and Recycled Materials for the Polymer Industry, with an emphasis on raw materials, really. So bioplastics is such a vast growing market with lots of new materials entering different parts of the plastic market. What I'm hoping to get across today is not only what we mean by bioplastics, but what are all the terms used when discussing this area. So as well as looking at some terminology, I will be showing how the current market sits, where it sits, how these materials fit into sustainability and the circular economy. And then I will look at biomaterials and how the classification of biomaterials and different material types. And finally, I will take a little time on the implications of using bioplastics on certain parts of the processing, but really the initial stages: storage, handling, and the processing of the initial processing, extrusion, for example, of these biomaterials. So when discussing bioplastics and recycling, you will come across a lot of different terminology and typical words you'll use, such as the words on the screen that you see: bio-based, compostable, biodegradable, degradable. How different is that? Renewable, sustainable. The circular economy, EOL, which is end of life, recyclable or recycled, green and greenwashing, I'm sure you know about. Environmental impact, environmental effect, carbon footprint, and then what is meant by in recycling, what is meant by PCR and PIR. All these terms I'll hopefully explain, and you'll have a better grasp of what they mean by the end of the talk. And hopefully explaining these terms will make it easier to understand bioplastics. So firstly, what does the term bioplastics mean? And well, the definition from European Bioplastics is a bioplastic is a family of plastics materials which are either bio-based or biodegradable, or both bio-based and biodegradable. What does bio-based mean? Bio-based means it is derived in full or in part from a biomass. This biomass could be corn, sugarcane, a cellulose source such as wheat straw, something like that. So now if we take a look at the current global production of bioplastics, and you can see that in 2021, the total production of both non-degradable and degradable bioplastics is equal to something like 2.4 million tons per year, which represents about 0.7% of the total plastics production globally. And this is if we use the 2019 figure, which I'm sure this changed, of 368 million tonnes per year of plastics. The trend for bioplastics has seen a large increase in the rate of growth in 2022, and it is predicted to double from the 2021 figure to something like 4.8 million tonnes per year, and then and it is predicted by 2026 to double from that figure, virtually double, up to about 7.6 million tonnes per year. And you can also see the orange, and each bar represents the biodegradable bio-based materials, and the green section represents the non-degradable bio-based materials. So the bio-based takes up about 2/3 to 3/4 in each bar of the total production of bioplastics. So if we now break down the global production capacities of bioplastics by material type, and this pie chart here shows that, and again this source is European Bioplastics, it shows that in 2021 the global production capacities of bioplastics, the total is 2.4 million tonnes, and the non-biodegradable bio-based takes up about 35.8% of this, and this incorporates bio-PE and bio-PP, bio-PA, bio-PEF. And then the bio-based biodegradable materials take up a larger portion of this at 64.2%, with PBAT and PLA taking up the largest portion at around 19%. These materials I explain in more detail as we go along. So how do plastics and bioplastics fit into sustainability and the circular economy? Well, currently plastics account for 20% of the chemical sector's greenhouse gas emissions, as stated by Plastics Europe. 26 million tonnes per year of plastics waste is generated. 25% of plastics currently goes into landfill in Europe, and the recycling rates in Europe are around 14%. The recycling rates in the UK would be slightly higher than that, at around something like 17%. We already know that recycled PET is a well-established recycle stream, and a bottle-to-bottle technology has been developed by recycling systems, such as the AREMA recycling system, which is a major recycling company. Recently, 100% PCR HDPE has now been FDA approved, which is it's a big development in recycled material. However, the main reason for low recycling rates right across the globe is the lack of collection of materials, and this is one of the biggest. This is one of the major stumbling blocks. We are going to go on to talk about post-consumer waste, post-consumer recycled PCR, and post-industrial recycled PIR, and what are the differences between those. So firstly, what's the term PIR? So this is post-industrial recycled, and what does it mean? Well, this is waste generated during the manufacturing process, and this is a closed loop system where manufacturing facilities collect waste and reuse it to make the same product. It could be anything from film to metallized film to flake. However, PIR does have many benefits, but the disadvantage is to companies is it's not included in the 30% recycled materials target, as this has to be PCR. So the benefits of PIR are it does reduce the amount of primary raw materials while maintaining the same product quality. If you use PIR in-house, then you have less disposal costs, less disposal tariffs. You can use up to 100% of production waste. such as trims back into the process. And if these trims are integrated in line, then there's no storage of PIR on site. So if we now take a look at PCR, what does PCR mean? So post-consumer recyclate. So PCR comes from anything that consumers recycle, and the quality of the PCR is very variable, and it could be film, it could be coloured flake, it could be highly contaminated, high moisture levels due to washing. It could even contain non-plastic parts depending on the grade. And all of these lead to significant difficulty in reprocessing. There are many companies who specialise in recycling, as I've already mentioned. Arima is just one with an excellent record of recycling PCR. And the image on the right is from their very informative website. The PCR form itself requires gives high demands on the recycling process, such as making it difficult to get a stable process. The feeding is very difficult and can create low throughputs, and it also can create high wear on the screws and barrels. The process requires very efficient drying, efficient feeding controls, efficient filtration at the end of the barrel, and also good degassing. But ultimately, the final extrusion will be carried out on conventional equipment, or final extrusion or injection molding, whatever the final product is. But for this reason, the final pellet must have a consistent shape, color, and consistency to be used as a final recycled product. Okay, so if we now look at how plastics recycled and bioplastics fit into the circular economy, so instead of banning plastics, the circular economy takes a more holistic approach to the plastics waste problem. And this is based on the concept reduce, reuse, recycle. So reduce by designing the product better and by using less material and less different materials in the product, using less single-use plastics, of course. Then reuse by making products last longer, long life bags, reusable cups, compostable bags would all come under this category. And then finally recycle. And the targets here are all plastics should be 100% recycled. And then as a regulator for sustainability, the ISCC, which is the International Sustainable and Carbon Certification, has set up a system for certifying bio-based industrial applications such as biomaterials. And some of these materials have ISCC plus certification, which is globally recognized standard for recycled and biomaterials, but also provides traceability along the supply chain and verifies that companies meet environmental and social standards. And again, a reference for ISCC is on the bottom of that slide. So another more recent initiative is to meet recycling targets has been set up in Europe, and this is CFlex, which is the Circular Economy for Flexible Packaging. And this consists of 180 European companies, associations, and organisations, with their mission statement, mission circular, is to collect all flexible packaging by 2025, and ultimately use greater than 80% should be recycled and incorporated into new markets. And they use a 5-step roadmap to build this circular economy. This is to collect the materials, to sort and recycle the materials, to redesign the products using less materials, and identify further solutions for end of life, further technological solutions for end of life, which have a more economic, technical, and better outcome for the circular economy. And just I mentioned there, Dr. Brona Miller, who works at the PPRC. She is a CFlex advisor based at the PPRC. So we've mentioned best of life options, but what does end of life? What end of life options are there? What does it mean? So there are 4 end of life options, and and landfill is no longer an option. We don't want plastics in landfill. So there are currently, as we already mentioned, 25% going into landfill in the EU. The other options are mechanical recycling, which we've seen on previous slides, for durable plastics, for fossil-based durable non-biodegradable plastics, for bio-based non-biodegradable plastics. This mechanical recycling is an option, and then for biodegradable bio-based materials, then we have organic recycling, which is typically composting. The fourth option and this is for any plastic, is chemical recycling, where the end product could be a fuel, a gas, it could be generating heat, or even producing the monomer to further go on to manufacture the original polymer. And this latter area is an area of rapid growth and interest, which is becoming a viable end-of-life option. So we've looked at the end-of-life options for a product. What about the production of bioplastics? And this must be considered to get a true cradle-to-grave life cycle analysis. European Plastics has stated that currently only 0.013% of the world's agricultural land is used for bioplastics, and this is predicted to increase to 0.06% by 2026, which is still a small fraction, even when comparing it to land use for biofuels, as you can see from the graphic on the left-hand side. Oh, sorry. So if we dig a little bit further, then the question is posed: how do bio-based materials compare to fossil-based materials? For example, such as bio-based polyethylene. How does that compare to a fossil-based polyethylene? Well, bio-based plastics help reduce the carbon footprint, and this an example here is by replacing the European demand for fossil-based PE with bio-based PE. This would save 73 million tons per year of CO2. An example of this is Braskem, or a large manufacturer in Brazil, which have a capacity of 200 kilotons per year of biopolyethylene and polyethylene grades. And in Brazil, this uses, as you can see from the graphic on the right-hand side, this only uses 0.2% of the available arable land in Brazil. So this is we hear greenwashing a lot, and I just want to just what does greenwashing mean? What does it really mean, and what does it mean to the plastics processing world? And this is a table from the Sustainable Energy Group, and the definition from that is: greenwashing is the practice of making brands appear more sustainable than they really are. And companies would use cynical marketing ploys or simply changing the packaging of an existing product while continuing to use the same unsustainable materials. And the article this is from, it highlights where there has been where companies have lost in high court over false claims, and it also highlights on the right-hand side where companies who are sustainable and can back up their claims have found to give very good examples of sustainable products or services. If you refer to that article, there's a lot more examples of companies which have made false claims, and then companies which are actually very sustainable companies, usually because they have their claims are certified, or they have fair trade. They have many different certifications and regulations. So here, this is just one example, and it's just really for thoughts. You know, it's one example of where cardboard has replaced plastic packaging, and it's a very recent example. And it's Procter & Gamble, and they replaced a plastic pouch with a cardboard pouch, and their advertising says it's fully recyclable. It only contains 5% plastic, and it is saving up to 900 tons of plastic per year. But I think, although it is fully recyclable, what effect we have to ask? This does sort of raise questions. And although it is fully recyclable, what effect does the 5% have on the cardboard? Where does the 5% plastic actually go? Was the original plastic packaging 100% recyclable, or was it even made from recycled material? If not, why not? Were the same collection points used, and how good will the collection points be? What about the plastics in the actual pods themselves, which is a water soluble plastic? And then compared to using 900 tons of plastic per year, how much recycled paper is used in comparison? And ultimately, the question that would need to be answered is, what is the difference in the carbon footprint or the global warming potential between the two packs? That's obviously not something you can put in a pack, but it's something that it does raise those questions. So when it comes to certifying bio-based materials, there are some common standards, and two of them are the VinCut and the DIN standard. The VinCut standard is according to ASTM D866, as you see, and this can be bio-based if it has a carbon content. So even if it has a carbon content of only 20%, it still can be classed as bio-based. However, the label does not show the actual percentage, but it shows the number of stars, where 4 stars can mean greater than 80%, and then less stars, 60 to 80, 40 to 60. The DIN standard is for bio-based plastics, and this DIN standard considers the entire bio-based fraction, including bio-based oxygen, nitrogen, and hydrogen, compared to the non organic fraction. And this provides for certification, and provides a stamp for how much a DIN stamp for how much material is in there, between 20 to 50, 50 to 85, and then greater than 85. But it also has a bio-based logo, which can be used with this certification. So then just to touch on biodegradation and marking biodegradation on the final product, although this is not really about the final product, but I thought I'd just mention this. For the end user, the marking for there is marking for biodegradation, and in particular composting. And if products are going in industrial composters, they must meet this DIN standard 13432 compostable certification, which this standard states that after 6 to 12 weeks, they will have depleted to at least 90%, and this depletion means the conversion of the carbon into CO2. It's not a weight, it's actually a chemical conversion of the carbon into CO2. So it means more than 90% by weight. Doesn't mean that. So we've looked a little bit about the background, the trends and stuff, but now if we look at the classification of plastics, and this infographic, this again is sourced from European Bioplastics. However, when discussing classification of plastics and bioplastics, it would be difficult not to come across a version of this graphic. So what this is showing is, firstly, on the vertical axis, this represents from the bottom fossil-based materials, and at the top up to bio-based materials, and the horizontal axis represents on the left non-degradable materials, and on the right degradable materials. So there are really 4 areas that all thermoplastics will fit into one, or sometimes there will be a crossover when it's partly bio-based. So conventional fossil-based plastics such as PP, PE, PET fit in the bottom left. So they are fossil-based, non-biodegradable plastics. The top right then represents the top left then represents non-degradable bio-based materials, and the top right represents biodegradable bio-based materials such as PLA, PHA, PBS, and starch. And then the bottom right represents fossil-based biodegradable materials. So these are materials which are produced from non-renewable resources but are biodegradable, such as PBAT, PCL, and all of these materials I'll discuss in a little bit more detail. So firstly, if we look at bio-based non-degradable materials, and these, a very common term used in the industry is drop-ins, and drop-in plastics are classed as bioplastics, and however their chemical structure is identical to the fossil-based counterpart. For example, a bio-based polyethylene has the same chemical structure as a polyethylene. So the basic backbone will be the same of the chemicals. So a drop-in means a bio-based durable plastic is another term people use. They are non-biodegradable, therefore they can be recycled. Because they are durable, they also require mechanical, chemical, and thermal recycling or recovery, but they can't be composted. And some examples of these, for example, we've already mentioned Braskem, who produce bio-PP, bio-PE, and co-polymers of PE like EVA. They are made from sugarcane, and Braskem has a capacity of something like 260 kilotons per year. And just as to put this into context, ExxonMobil production of PE is about 1.1 million tons per year of polyethylene. That's just as a comparison. Other drop-in plastics, bio-based, non-biodegradable would be biopolycarbonate, bio-PC, which are produced by both Covestro, which is partially bio-based, and also SABIC, produced polycarbonate. Again, this is 50% bio-based, but in this case, it's from waste oils. And the SABIC bio-PC has a ISCC plus designation. Another material is PEF, which is it's a new material which I'll go into a little bit more detail about, but it has a flagship plant in the Netherlands, producing 5 kilotons per year from plant-based sugars. Okay. So if we now look at bio-based biodegradables, so that's the top right of the quadrant of the chart, and these are materials which decompose or biodegrade in industrial composting conditions. And PLA is historically the most well-known of these. However, it is not liked by many retailers or end users for packaging due to its slow degradation in composting sites. It does block up anaerobic digesters, and typically it's a very rigid film and fairly noisy on processing equipment. PHA is the rising star, but it has been around for a long time. But due to investment and development of more robust raw materials, it has grown in popularity. Again, I'll go into a bit more detail on these. And bio-PBS is a partially based biodegradable material, which biodegrades in compost, in both industrial composting and home composting. There are a few suppliers, but a joint venture between PTT and Mitsubishi Chemical Corporation has a facility producing about 70,000 tons per year of bio-PBS. Another important player in this area in bio-based biodegradables is TPS, which is thermoplastic starch, and this would be supplied by companies specialising in starch products. And one of these is a company called Agrana, who produce TPS. However, to make TPS more functional, it needs to be blended or compounded. So it has another process with another biopolymer to produce something that is more usable, such as a flexible film or injection molding parts. So just going back to PLA, as you've said, it's historically one of the most commonly used bioplastics, and there are many suppliers. However, NatureWorks and Total Corbion are two of the larger producers, with capacities of 150 kilotons per year and 75 kilotons per year, respectively. So that's 150 for NatureWorks. PLA is relatively easy to process in line with conventional equipment and conventional materials. It's so it's not a big step for producers. However, it is PLA, polylactic acid, is a polyester, and like PET, it requires drying to very low moisture levels. The disadvantages, a disadvantage of PLA is that it decomposes relatively slowly in composting sites, and it's a fairly hard, clear material, which I've already mentioned. However, it is being commonly blended with more flexible and compostable biomaterials to make the PLA much more usable. It's still a very common material, which is on the increase. That slide is from NatureWorks. It's just a product from NatureWorks, and it's just an example of some of the products. I won't dwell on that slide too much, but you can see typical rigid products, typical flexible films and wovens. 3D printing, the default 3D printing filament is PLA, so most people would use PLA if they're designing for 3D printing. So if we move on to another material, another very important bio-based biodegradable material is PHA, which is polyhydroxyalkanoate. And this is really, PHA is a generic name for a family of materials, and there's lots of different grades. These materials would be known as PHBVs or PHBs, depending on the chemical structure. And they do vary quite a lot in their processing and final property characteristics, so they can be fine-tuned to the end property requirements. And there are many producers of PHA across the globe, and one of these is Danimer. And Danimer is expected to have a capacity of about 30 kilotons per year in 2022, and it is estimated that the global capacity, which is quite significant, of PHA is expected to be over 1 million tons per year by 2023, which is quite significant if you think about the ExxonMobil LDPE production site. This growth of PHA, this recent growth of PHA, has evolved due to the development of more robust raw material grades, which can withstand the intensity of polymer processing, just to give it give you a much more stable process. The main advantage of PHA is that it is fully compostable, and it can be flexible or rigid. However, like PHA, like PLA, sorry, PHA is a polyester, and it requires very efficient drying protocols, but also requires good extrusion controls, such as temperature controls, due to a very narrow processing window. So finally, of the four sections, if we look at the fossil-based biodegradables, so this is where we use fossil-based materials to produce a biodegradable material, and PBAT is probably one of the most well-known, and it has been well-established materials. And this is a very flexible material, which is used for flexible films, but it also has excellent compatibility with other biomaterials such as PLA, PHA, and thermoplastic starch. And its one of its typical applications is for compostable caddy bags. There are several suppliers of PBAT, and EcoFlex by BASF is just one of these, and they have a capacity of something like 60,000 tons per year. Another fossil-based biodegradable, which has been around for a long time, is a PCL, or polycaprolactone, and this is important. This is a very important low-temperature biomaterial, which is used in more niche areas, such as medical devices. However, outside of the more niche areas, it can be blended with other biomaterials for producing flexible films and sheets. However, I think that in terms of cost, it is a higher cost than other biomaterials. Another very interesting fossil-based material is PGA, which is polyglycolic acid, and Curodux, which is produced by a company called Curaha. This material is another rising star. It is a fossil-based biomaterial, but it has excellent flexural and tensile strengths, as well as wear properties, which historically was used for medical sutures, but now with an industrial scale production, it is expected to be able to compete with the likes of PEEK in injection molding parts. So you're talking about a biodegradable material which has the strength and wear resistance similar to PEEK. So that this is expected to be a rising star in the future. Okay, I've mentioned the materials and the different types of materials. We're just going to have a look at how these materials will impact on polymer processing. And this graphic is just showing the different stages of the extrusion process. But today I'm only going to focus on the first two stages, which is all to do with the storage of these materials. Do they need drying? What are the pellets like? And then once they are processed on an extruder, how does this affect the what implications does it have on the melt behavior? How do they perform effectively? How do they perform in the extruder? So firstly, if we look at how we store and transfer biomaterials, most biomaterials are hygroscopic, so they will very readily absorb moisture, and any moisture present, if that's then put in the extruder, that will severely degrade the polymer in the extruder. It will break down the polymer chains, and you will have no control, and you'll not be able to make an acceptable product. So these resins are supplied typically in foil bags for this reason, but it's also usually recommended to dry these materials to moisture levels of something like 0.04% or even lower. And for this reason, inline drying would also eliminate any moisture uptake. So this would be a culture change to lots of processes, film processes in particular, who are only used to processing LDPE or polypropylene. And there may be an investment in drying, inline drying, or offline dryers. But it wouldn't be such a big culture change for companies who are familiar with polyamides or PETs. The granules themselves can be very different in shape, and in particular, PLA is a very hard, incompressible pellet. So that must be considered, you know, and when blending, whereas something like a TPS, it would be a much softer material. Also, if there's any the design of the screw, if there's any areas within the extruder where material can be hung up, then this would potentially cause issues in terms of material degradation. Okay. So if we just move on now to how will these materials perform during the extrusion process? So the most common observation really is that most bioplastics are processed at lower temperatures than conventional materials, and this is usually less than 200 degrees C, and almost all have a narrow processing window, but this is particularly evident with PHA, where the temperature of the processing temperature and the screw speed can affect it's fairly sensitive to both temperature and screw speed. And this is because as the melt viscosity can change substantially across even a 10 degrees C temperature range, which can change the extrude rate from a running liquid to if the temperature is too high, or cause high torque from a viscous material if the temperature is too low. And some of these materials, such as PHA and TPS, will have unfamiliar aromas, smells, which there's lots of conventional materials have aromas, but this is again a culture change, because these smells, for example, TPS is starch, so it will have a starch smell. So that this also has to be considered. So I've already said that there must be no stagnant areas such as groove feed. So groove feed extruders are not recommended for biomaterials. Some biomaterials such as PLA may be harsher on certain steels if they're not corrosion resistant. So if we are moving it to PLA, maybe more corrosion resistant steel for screws and barrels may be required. And in some cases, there will be specialist protocols for starting up extruders to minimize degradation at the start, and for shutting down extruders to eliminate all biomaterials. So there's just new protocols that must be looked at. Okay, so finally, I would just like to finish off by looking at going quickly over and looking at the future challenges and opportunities for growth in the bioplastics market. So firstly, the volumes of bioplastics produced are only about 1% of the total plastics market share, as I mentioned, although this is expected to double by 2022. However, some bioplastics suppliers are only increasing capacity in line with customer orders, and some producers would be working. A lot of them would be working with the end user rather than the processor. The current prices of bioplastics are still higher than fossil-based materials, and customers will always tend to opt. Lots of customers always tend to opt for the lower costs. If we are switching from polyethylenes or polypropylenes, then the processor must buy into the new material handling and storage protocols, such as drying and keeping the material dry, and this could be new to them. The processing of these polymers also require a learning curve, as a lot of these biodegradable bioplastics require better production controls. The final properties and end user acceptance is another challenge, and this is something to be discussed another day due to the many different types and properties of these bioplastics. I've mentioned them briefly. And then finally, the legislation and new regulations, I've touched on them, for plastics waste and for certifying biomaterials must be seen as an opportunity to both improve recycling and to find the most suitable products for using biomaterials, and finding the best end-of-life option. This area of legislation, and particular plastics taxation, is something that will be covered in the next presentation. Okay, so thanks very much for listening, and I look forward to some questions, and I'd like to maybe pass you back to Shane, if that's okay.
Okay, Mark, thank you so much for that. So I'll just put you live for a moment here, Mark, just to say that was extremely comprehensive, and thank you for sharing that with us. A lot to take in. I'm sure we'll have a little discussion maybe with Alan in the Q&A session a little bit later on some of the observations on it, but clearly a huge topic to try and get our minds around. So at this point, you've mentioned there that we have an expert with us today in the form of Bertil Kapff. So I'm going to switch over to Bertil now at this point. So hopefully, Bertil, you'll be coming on screen. Welcome, Bertil, to the webinar.
Thank you for organizing this webinar, and yeah, I'm happy to share my thoughts on plastic tax today.
Excellent. Bertil, I suppose it's obviously the technical areas come from the team in the PPRC with Mark and Alan. Obviously, the area that you're going to address for us is around the area of regulation. and in particular taxation. So with that, I should be able to hopefully bring on your slides in a moment. So.
Thank you. So I can already see them. I hope also the participants. So maybe I just introduce myself. My name is Bertil. I'm a tax consultant at WTS in Düsseldorf, Germany, and I worked there for 10 years in excise taxes, so all the taxes which are mainly charged on products. My main focus in the past was the energy taxation, but now since 2021, if we go to the next slide, where you can see there was a change in regulation on the EU level. The EU made a new directive on how they are calculating the budget. So this means the fees which have to be paid by the member states. So not you as a company, but like the member states like Germany, Ireland, Sweden, or comparable. These countries, they have to pay since the 1st of January 2021 a contribution to the EU budget, which is calculated by the amount of plastic waste which they put into market. Where you calculate the amount of plastic waste placed on the market, and you subtract the amount of recycled plastic. So this is really important. What we heard today from the colleagues from Belfast University. So the way you choose your products today will define of how many plastic tax you will be charged in future. The amount of unrecycled plastic is the subject of how this contribution to the EU budget, which is, as I already said, has to be paid by the member states, not by the companies, is calculated. And as you can see here on my slide, it's the revenue which is projected for this new levy, which has to be paid by the member states, is around 7 billion euros per year. It depends on each country, obviously, how much they have to be charged. It's also one big mistake which is often made. It's not that the countries they have to pay, or the member states they have to pay more than before. It's just the way how you calculate their contribution to the budget. It has changed. Before it was only about the gross national income. It was the way you calculated the amount they have to pay. Now it's the plastic levy is one key element there to calculate the amount of contribution to the EU. As we learned now, the member states, they have to pay this amount of money to the European Union. Now they obviously they don't want to just have to pay, but also they are looking for ways how to receive to refund their money, and also to make it in a way which they can explain to their voters. And it's it's obvious decision that the countries decide. Now we are starting to implement new taxes as we have to pay this new levy, and the plastic tax is the obvious way. If you just charge the amount which you have to pay to the European Union to the producers and importers of plastic, which are obviously the most easy person which you can address here. One thing I have to add on this way before we go to the next slide, you don't have any European legislation how the different member states are implementing the taxes. There are countries, we can just go on to the next slide. Here you can actually see a map. Yes, exactly. Now I can also see it. Where you see that some countries where already have implemented taxes. This is the orange looking countries here, like Denmark. I think it's already been implemented in 1991. Also Romania, they have it like 2005. They have really an old tradition on plastic taxes, but now because there's this new levy, where also the other countries are starting to implement these new taxes. Maybe I will highlight the UK. Obviously, UK is not part of the European Union anymore, but even before they started a project of implementing new plastic taxes, without going into detail in this high-level overview, on the 1st of April, the UK plastic tax already took into effect. So here also we already have this regulation now, and which makes it interesting for you to change the kind of material which you use when you produce plastics or similar items. What I want to highlight also is the red countries, because here obviously there's something which can happen really close. Spain and Italy, for example, they want to start their plastic tax on the 1st of January 2023. So it's really close. It's in 3 months already. It should be starting. But here also, like in Spain and Italy, they already postponed it 3 times each. So actually now, because there's the economic crisis, the energy crisis, it may be possible that there may be some delays, but actually the Spanish government, they already said they wanted to start it now. Germany, here we have it's on the yeah, in the middle of a map, obviously. They said, the government said already they want to implement it, but we do not have draft legislations or anything similar. It's just here that the government said that there's a plan. If we continue to the next slide, I just have here the supply chain of plastic. You probably are more informed than I am how this works. I'm a tax consultant, so I mainly here on the tax side of a problem, but you see the pictures and you see what I wanted to express here with my slide. There are different processes on the value chain. Here today we are obviously on the plastic production, on the second level of his slide. What do I want to express with this chart? It is possible to implement the plastic tax on each level of this supply chain, of this value chain, and it's just really on the decision of a member state. Every country is free to decide which level of a value chain they want to put a tax on, and it's there's no fixed regulation. So it's for you, if you just take one sentence from what I say today, it's you have to look at each country individually. It's not one rule for everyone. So if you now figure out how the UK plastic tax works, it doesn't help you for Spain, it doesn't help you for Italy. You still will have to figure out in detail if you put plastics, as I said, this most of the time, this is why they are highlighted here on the slide, the importers and the producers of finished goods. They are most of the time the yeah, the payers were liable to pay the tax. We have to do the tax declarations, but it does not mean that it's maybe totally different in other countries. But nevertheless, if you're a producer of plastics, you will have to look up how the regulations are in the individual countries, and in order to fulfill your clients' needs. And this is the way which kind of plastic will be demanded in future. If we continue to the next slide. Here I put it for you, as an example. As I said, it's different in each country how the UK plastic tax is implemented, how are the different rules. For you as a producer of plastic, probably the second point is the most important one. Here you can say not in the range of the plastic taxation is plastic which is contains at least 30% of recycled plastic. So if you change your way of production, if you use more recycled plastic, if you use also which we learned today, biological plastic, then you may be get out of the scope of these new taxations, and then obviously your product is not charged by plastic tax, and you can you can offer your products cheaper than your competitor. Here it's really it goes a little into detail. for the ones which are already concerned here, which are putting plastic into the market in the UK. Maybe it's worth to hear. You have a threshold of 10 tons per year of plastic packaging, which is not taxed, but you have to do a lot of declarations, and also you have to be aware it's a tax subject, and you have to be prepared for checks by the authorities. You also see here the amount of tax which is charged by the UK, 200 pounds per ton. Maybe as a little comparison, the EU level levy, as I said, the plastic levy, not the plastic tax, is 80 cents per kilogram, so it's a lot less. Also the Spanish tax, it's and also the Italian tax, we are projected to be 45 cents per kilogram, so it's less than the EU level tax, but this is also just, it's the first it's the first approach. There may be changes in future. And also, as I said, if you're affected by this tax, you have to look into detail. Here is maybe also the last point of a slide where you see if you export plastics, they are not subject to tax, but if you import plastics, they are subject to the tax. So you have to have a really good monitoring about which kind of how your supply chains are, which products you produce, which products you export, which products you import, in order to make the necessary declarations to the authorities. Just one sentence on the next slide to Germany. I think I already said it. Here we have this coalition agreement. Our government said we want to implement the plastic tax, but as I said, there's no draft law, so I don't want to put it into detail. Just as you can see, Germany is paying 1.4 billion euros to the EU budget, and now they're trying a way to finance it. Especially now with the energy crisis, we're putting on very much help for citizens, for companies, and there needs to be a way how we can refinance all these projects, and the plastic tax is one way of it. Now to conclude my my saying, on the next slide you find actually what you have to do as a company. I think this is always important to see. As I said today, it's just a high-level overview, but what is changing for you, because you learned today, since 2021 there is this project in the different EU member states. The first thing which you should start today is to look up in all countries in which you operate, which is which are the developments there. Are there some kind of is there an introduction plan of plastic tax? Are there maybe already plastic taxes, in order to be prepared and not to be surprised if your business will change because of new regulations. I just want to highlight or make some advice here. We from WTS Global, you can find it on the internet, made a little report of this. We asked our cooperations partners in all Europe how there is the developments are, and you can look it up in a few ways. It's for free, downloadable on our website. You just look up for plastic tax WTS Global, and you will find this free report. On the next step, when you have to find, as I already said, you have to look up your supply chains, your material flows. You have to find which material is subject to tax and which material is not subject to tax. As I said, it's really dependent on each country, and it's also like the definition of the taxable subject. Is this kind of material, this kind of plastic subject to tax or not? Is this kind of production? Maybe is there's an exemption? This is the second point of view, and actually when it goes into detail, you have to make this you have to talk to, obviously, to your suppliers and to your customer, because in the best way the tax only has to be paid once in the supply chain. We saw it on my second slide, or my third slide, which kind of but there's a lot of people integrated in this supply chains, and if you have a declaration that your supplier already paid the tax, In the best case, you do not have to pay it anymore. But as I said, it's mainly a compliance project. Also, if you can see the amount of tax which has to be paid compared to the cost of plastic, most companies they say it's the cost of compliance in the most times it's as high as the cost of the plastic tax itself. So it's actually you have to make your declarations right in order to fulfill all the requirements from the authorities. And step 4 and 5, it's actually just a operational tax compliance. It's registration to the authorities, and also like a regular handing in of your tax return. Obviously it is as you do it with other taxes also. Just to finish off my last slide, 2 more sentences. Plastic tax is not the only regulation, as also the Mark already pointed out today. There are a lot of new regulations in plastics. Probably the most which has the most effect on your business would be if there would be a new ban on single-use plastics. If some kind of plastics will not be allowed to be put on the market anymore. We have this new regulations for extended product responsibility, littering costs. It's also there are new EU regulations. Just for you to give you some keywords, if you put plastic onto the market, if you're a manufacturer in this area of business, be sure that you look at all these different aspects of a production of plastics in order to be compliant and in order to fulfill all your requirements. So yeah, thank you. If there's any questions, I'm happy to answer, and I'm happy for you to for this organization of this great webinar.
Thank you very much, Bertil. A very comprehensive overview, very succinctly put together from your perspective on the taxation and regulation. Thank you very much, Bertil. So at this point, hopefully we should be able to move over to another presentation. Okay, so we'll just move this over slightly. Okay, hopefully you should see the Q&A session coming up here. So at this point, I'll just invite Alan, Mark and Bertil to unmute yourself just for a moment, just for some passing comments. Just from my perspective, gentlemen, just in summary, it's clearly this is really a multifaceted topic in terms of the circular economy, in terms of the new materials that are coming on stream for plastics producers to deal with, for suppliers to deal with. Clearly there's levies at a European level, at a country level. There's new regulations coming on stream, as Bertil has outlined as well. And I would say that it's clear there's so much expertise that's been offered today from Mark, from Alan and the team in Brona in the PPRC in Queen's University Belfast, and obviously Bertil and the team in WTS. So firstly to say thank you very much for your contributions, gentlemen, and really very, very comprehensive. This is clearly, it's a growing area. From the technical materials to the evolving regulations, as we mentioned, there's challenges not only from an environmental perspective that we're all aware of at a consumer level, but there's also processing challenges, as Mark has highlighted during the presentation. Even just to remember all of the different acronyms, Mark, is a challenge. So clearly there's a lot of new materials coming along, and distinguishing between biomaterials that are combustible or compostable or not compostable, and the regulations that come in, as Bertil has highlighted as well. I would note in particular, there is an excellent paper, Bertil, that you highlighted on plastics taxation in Europe, an overview that you have published with WTS. I think from a business perspective, it's a very good starting point. I would encourage all of our participants to have a read of this paper. And it seems like the regulations, it's not a question of if, it is definitely a question of when. So this is an evolving topic that we'll certainly be looking at. Just from in terms of next steps, and I'm sure this has obviously been very thought-provoking. Hopefully on screen you will see. Hopefully you should be able to see some contact details for the. Let me see 1 second here. There should be some contact details. Hopefully coming up on screen now in a moment. Just 1 second. Hopefully you should see some contact details coming on screen now. For the PPRC in Queen's University in Belfast, for WTS, and for ourselves in TSM. The upcoming exhibition, the global show, the K Show, running in Dusseldorf from the 19th to the 26th of October. We will have a booth there in Hall 10 on stand H36, and there's an open invitation for any of you as participants to come and engage with us. We know Queen's will be on hand for a period of the exhibition, and also some of the colleagues from WTS will be on hand during the exhibition to engage with you, to talk about these new materials, some of the processing challenges you may have, some research projects, and other areas that are affecting your business. As we've mentioned, and probably repeating ourselves, it's an evolving topic. There's clearly technical evolution, there's processing challenges with it, there's regulation challenges with it, and there's also pressure, let's say, for all of us at an environmental level to address the problem of the circular economy quite urgently. So at that stage, again, just to thank Alan, to Mark, to Bertil, for all of your contributions today. They've been really, really appreciated. And finally, just to say thank you very much. And hopefully we will all engage with you soon at the K Show, if not before. Thank you very much, everybody, and take care.
Thank you very much, Shane.
Bye, Shane. Bye, everyone.
Thank you, Shane.